Students, once again we are discussing same question which we leave last time. So here ABCD is a string suspended from points A and T, and it carries a weight 20 kg and at B a weight W kg at C. The points A, B is horizontal, BC, CD makes an angle 60 degree and 30 degree with vertical. Find W and tension on the portion of the strings. So, students, see this A, B, C, D is a string suspended from the points A and D. It carries a weight 20 kg at B, W kg at C, a weight W kg at C. The portion of AB is horizontal, and BC and CD makes BC and CD makes an angle 60 degree and 30 degree with the vertical. So, be very careful here, the angle they makes with vertical. I repeat, angle with vertical, and the angle with vertical means angle with this line. Angle with horizontal means angle with this line. X-axis, angle with y-axis, and the angle here 60 degree and 30 degree. So, let the forces acting in equilibrium at B are, since forces are in equilibrium, so from at B the forces are in equilibrium. The forces are 20 kg downward, T1 tension on BA and T2 tension on BC. So, tension T1 in the string BA, tension T2 in the string BC, and weight W kg vertically downward. By Lami's theorem, since three forces are in equilibrium, so by Lami's theorem, T1 by sine of angle between 20 kg and T2, that is 60 degree. T2 by sine of angle between T1 and 20, that is 90 degree. And 20 by sine of angle between T1 and T2, that is 90 plus 60, that is 150. So, once again, students, see these angles very carefully. T1 by sine by Lami's theorem, T1 over sine of angle, T1 over sine of angle between T2 and 20, T2 by sine of angle between T1 and 20, and 20 by sine of angle between T1 and T2. So, I put the value of 60 degree, that is under 3 by 2, sine 91 and sine 150 is 1 by 2. So, I got T1 is equal to 20 under 3 kg and T2 is equal to 40 kg. The forces acting on equilibrium at C, forces are equilibrium at C also, and we want to find W also, T1, T2 we find, and we want to find W and tensions also. So, this tension T3 on CD, tension T2 on CB, and weight W kg vertically downward. Again, by Lami's theorem, T2 by sine of angle between W and T3, that is 30, 180 minus 30, that is 150. T2 by T3 by sine of angle between T2 and W, that is 120 degree, and W by sine of angle between T2 and T3. So, this angle is 90 degree. So, I put these angles. If you find any difficulty, then you can ask again and again. T2 by sine of angle between W and T3, T3 by sine of angle between T2 and W, and W by sine of angle between T2 and T3. So, put these value, we got T3 is equal to 40 under 3 kg and W is equal to 80 kg. One more question, see. A string ABCD attached to two fixed points A and D has two equal weights each of 30 kg knotted to it at B and C and rest with the portions A, B and C, D at angle of 30 degree and 60 degree respectively. To the vertical, be very careful, to the vertical. Find the tensions of the portions of the string and the inclination of BC to the vertical. Just see the figure first of all. Here we have A, B, C, D, 4 points are there. 2 points fixed, the fixed points are A and D, and a weight 30 kg is noted at B and C, 30 kg and 30 kg. AB and CD makes an angle AB and CD makes an angle 60 degree, 30 degree and 60 degree with the verticals. Now at B and at C, the system is in equilibrium. When system is in equilibrium, so forces at B and forces at C are in equilibrium. So since let BC makes an angle, BC makes an angle theta, we want to find this angle theta. The forces acting in equilibrium at B are tension T1, tension T2 and the weight 30 kg vertical downward. They are in equilibrium. So by Lami's theorem, T1 by sine of angle between 30 and T2, that is theta. T2 by sine of angle between T1 and 30, so total angle is 180 minus 30, that is 150. And 30 over sine of angle between T1 and T2, and the sine of angle is 90 plus 30 कर लिए, जहाँ 180 minus theta minus 30 कर दिए. So this is T1 by sine theta, T2 by sine 30 and 30 by sine 30 minus 30, theta minus 30 degree. So the force is acting on equilibrium at C ते भी equilibrium है we. Then tension T2 in the string CB, T3 on CD and 30 kg vertical downward. So again by Lami's theorem, T2 by sine of angle between T3 and 30, that is 120. T3 by sine of angle, and this angle is 180 minus 30, and 30 by sine of angle is 60 plus 30 degree. So on simplification of this, T2 we got 30 into this, and we got 15 by sine 30 minus theta minus 30 degree, and here also, so 15 by sine theta minus 30 degree is equal to 15 under 3 by sine 60 plus 30. On simplify, we got T2 is equal to T2 from here and T2 from here, both are equal. So that's why we write in this way, and we got 15 under 3 by sine 60 plus 30 degree. So on multiplication to left side and simplify it, ultimately we got tan theta is equal to 1 root 3 and theta is equal to 60 degree. This is very easy for the student who are in B.Sc final class. Similarly, what is T1 and what is T2 and what is T3? So after putting the value of 30 is equal to 60 degree, we got the value of T1, T2 and T3. Another question. A uniform plane lamina in the form of rhombus, one of whose angle is 120 degree, is supported by two forces applied at the center in the direction of the diagonals, so that one side of the rhombus is horizontal. Show that if P and Q be the forces and P be the greater, then P square is equal to 3Q square. So I have a square lamina, plane lamina in the form of rhombus, and then A, B, C, D, and the forces applied P and Q, the forces P and Q, where P is greater than Q. Now we show that P square is equal to 3Q square. So this is our lamina. This angle is 60 and 60, 30 and 30, and this angle is 60 and 60. Let ABCD be the rhombus whose angles BAD is 120 degree, BCD is 120 degree. Let the diagonal AC and BC meet in O. Since P is greater than Q, so P act along OC and Q act along OD. Forces acting at O are force P along OC, force Q along CD, and weight W kg vertically downward. Since these are concurrent coplanar forces and are in equilibrium, therefore by Leibniz theorem we have, and Leibniz theorem says P by sin 60, P by sin 60, angle between these two, and then Q by sin 30 degree, W by sin 90 degree. So when we put these values, we got P is equal to root 3 Q, and squaring both sides we got 3 P square is equal to 3 Q square. One more question I am taking, and after that we will see how student can do it. A string is tied 2 points. String is tied to 2 points at the same level, and a smooth ring of weight W kg which can slide freely along the string is pulled by horizontal force of P kg weight. In the portion of the equilibrium, if the position of is equilibrium, the string are inclined at an angle 60 degree and 30 degree to the horizontal. Find the value of P and the tension in the strings. So this is our figure. 2 point A and B. Let's see. Let A and B be the points to which the string is tied, and T be the tension in the strings. So tension T along CA, tension T along CB, and horizontal force P. This horizontal force, this is extra horizontal force, is pulled by a horizontal force P kg weight, and W be the vertically downward. So here we have 4 forces T, T, P and W. So we apply resolve part along horizontal direction and along vertical direction. So how we resolve? So T into x is equal to T into cos 30, T into cos of 180 minus 60, that is 120, and P into cos 180 degree, W into cos 270 degree. Student, this way we can write, or we can write in this way, but the answer remains same. So T into sin cos 30 degree, P into this one cos 120 degree, P into cos 180 degree, and W into cos 270 degree. After simplify that or simplify this, we got P is equal to this. Similarly, along horizontal and along vertical, so T cos 60, T sin 30, T sin this angle 120 degree, P into sin 180 degree, and W into sin 270 degree. So this is a horizontal and vertical. So we got W is equal to this, T is equal to this, and T is equal to root 3 minus 1 W. So P is equal to P. What is P is equal to T? T the value, we put the value of T and we got answer. So that's all. One more question is there. So I suppose that this is the same, just the force, horizontal force is in this side, the remaining is same. So I leave this question for the students. If you find any difficulty, you can ask me anytime. So I leave the question here. Thank you.